Welcome back to Max with RP. Today we are going to continue with the technique that we learned in the earlier lesson or in the earlier video, that is how to integrate functions of the form 1 by x power 4 plus 1. Today we are going to see how to integrate functions which are reduced to that form, and we will use a similar technique. For example, let us look at this function, how to integrate root tan x dx. So I am going to put root tan x as t. Then what will I get? Tan x will be t square. Differentiating this, secant square x dx will be 2t dt. But what is secant square x? Secant square x is 1 plus tan square x. Dx is 2t dt. If I write in terms of t, tan x is t square. So tan square x will be t power 4. So dx will be 2t dt by 1 plus t power 4. If tan x is t square, tan square x will be t power 4. So 1 plus t power 4. So can be now written as integral of, what is root tan x? T. What is dx? 2t by t power 4 plus 1 dt, or I equal to integral of 2t square dt by t power 4 plus 1. So now I am going to rewrite this as I equal to integral of t square plus 1 by t power 4 plus 1 dt minus t square minus 1 by t power 4 plus 1 dt. So t square will get cancelled. 1 plus 1 will give you, this should be plus t square will be 2t square plus 1 minus 1 will get cancelled. Denominator is t power 4 plus 1. Now I can write I as, by dividing by t square, 1 plus 1 by t square dt by t square plus 1 by t square, plus integral of, when I divide by t square, I will get 1 minus 1 by t square dt by t square plus 1 by t square. So I have reduced this into two integrals. Now I am going to write this in terms of t minus 1 by t, because 1 plus 1 by t square is a derivative of t minus 1 by t. 1 minus 1 by t square is the derivative of t plus 1 by t. So now we have 1 plus 1 by t square by t square plus 1 by t square dt plus, so I am just rewriting this step, 1 plus 1 by t square plus 1 minus 1 by t square plus 1 minus 1 by t square by t square plus 1 by t square dt. So now if I take u equal to t minus 1 by t, my du will be 1 plus 1 by t square dt. Now u square will be t square plus 1 by t square minus 2. So t square plus 1 by t square will be u square plus 2. Okay. Now this is for the first integral. For the second integral, I am going to take m as t plus 1 by t. Why? Because then dm will be 1 minus 1 by t square dt. Now m square will be t square plus 1 by t square plus 2. So t square plus 1 by t square will be m square minus 2. So the whole thing is now reduced to integral of, writing it in terms of u and m, this 1 plus 1 by t square dt is du. So this you can write it as du by u square plus 2, then plus integral of dm by m square minus 2. Now this is of the form x square plus a square, but a square is 2, so a is root 2. So what is the formula for integral of dx by x square plus a square? 1 by a tan inverse x by a. So 1 by root 2 tan inverse u by root 2 plus 1 by 2 root 2. Here a is again, this is the form integral dx by x square minus a square. What is the formula? 1 by 2a log mod x minus a by x plus a. A square is 2, so a is root 2. So 1 by 2a log mod m minus root 2 by m plus root 2 plus c. Now we have to substitute back for u and m. So I will be 1 by root 2 tan inverse. What is u? T minus 1 by t by root 2 plus 1 by 2 root 2 log mod m is t plus 1 by t minus root 2 by t plus 1 by t plus root 2 plus c. So the function was reduced to the form 1 by x power 4 plus 1, and a similar technique what we use for 1 by integrating functions of the form 1 by x power 4 plus 1 has been used to complete the problem. Now look at this. Suppose you have integral of root of cot x dx. So what will happen? Root of cot x, I am going to write it as t. That is cot x equal to t square minus cosecant square x dx will be 2t dt. Minus cosecant square x. Cosecant square x is 1 plus cot square x, 1 plus t power 4. So dx will be 2t minus 2t by t power 4 plus 1 dt. So I will be equal to integral of root of cot x is t minus 2t by t power 4 plus 1. This will be minus 2 in minus 2t square by t power 4 plus 1. This is, in the previous sum we had plus 2t square, here we have minus 2t square. So same procedure we can use, minus of integral. So how did we write? T square plus 1 by t power 4 plus 1 plus t square minus 1 by t power 4 plus 1. So the same process can be used. What was the process? We divided by t square. So this will be minus integral of 1 plus 1 by t square by t square plus 1 by t square minus integral of 1 minus 1 by t square by t square plus 1 by t square. So this will be minus of, since the same type I have done in the earlier problem also, I am going to take u as, if I have to get 1 plus 1 by t square as a derivative, t minus 1 by t. So numerator will be du by t square plus 1 by t square will be u square t square plus 1 by t square. When I square, I get u square equal to t square plus 1 by t square minus 2. So t square plus 1 by t square will be u square plus 2 minus dm. What will happen to this? This will be m square minus 2. Because 1 minus 1 by t square is the derivative of t plus 1 by t. So both are accompanied by minus sign because of the minus sign outside. So this is minus 1 by root 2 tan inverse u by root 2 minus one by 2 root 2 log mod m minus root 2 by m plus root 2 plus c. Substitute back for u. U is what? T minus 1 by t. M is t plus 1 by t. So you can substitute back for u and m. Then you get the solution. Are you able to follow? So we have done root tan x. We have done root cot x. Next function that we are going to integrate is the sum integral of root of tan x plus root cot x dx. So to integrate this function, there are two ways. The longer method is write it as integral of tan x plus integral of root cot x. Do what we did earlier, integrate them separately, bring them to the form of x power 4 plus 1 and integrate. Okay, and you have to do separately for both the functions. Alternatively, what we can do. So now I am going to write this as root sin x by root cos x plus root cos x by root sin x dx. So I will be equal to integral of sin x plus cos x by root of sin x cos x dx. Now the idea, one of the important techniques we are using is, in order to use integration by substitution, we have to choose whatever. If I want to write something as t, then I should have the derivative. So if this is the derivative, then what should be my choice of t? Let t, suppose I write it as sin x minus cos x. Then what will be dt? Cos x plus sin x dx. So cos x plus sin x dx will be dt. So I will be integral of dt by root of. Now how to write sin x cos x? I can write it as integral of dt by root of 2 sin x cos x. I am going to multiply and divide by root 2. Why? Because I know that I can write, when I simplify this, what will I get? T square is equal to sin square x plus cos square x, which is 1, minus 2 sin x cos x. So 2 sin x cos x is 1 minus t square. So this will be root 2 into integral of dt by root of 1 minus t square. This is of the form integral of dx by root of a square minus x square, which is sin inverse x by a plus c. So this is root 2 into, recall the formula for, this is of which form? Integral of dx by root of a square minus x square. A square minus x square is sin inverse x by a plus c. So root 2 into sin inverse t plus c. This is root 2 into sin inverse, what is t? Sin x minus cos x. Sin inverse, so this is by, see, this is of the form sin inverse x by a. Here a is 1. A square is 1, so a is 1. So root 2 sin inverse sin x minus cos x plus c. So if you are asked to evaluate the integral of root of tan x plus cot x, either you can integrate them separately using the process that was taught to you in the earlier problems, or you can combine them, simplify them, and use the fact that sin x plus cos x is the derivative of sin x minus cos x. So choose appropriately t as sin x minus cos x, then multiply and divide by root 2. Then you can write 2 sin x cos x as 1 minus t square. So this is reduced to root of 1 minus t square, which is dx by root of a square minus x square, which is sin inverse x by a. So root 2 into sin inverse t by 1 plus c. Then substitute back for t as sin x minus cos x. So I hope you understood how to evaluate 3 important functions. One is root tan x, other is root cot x. The third one that we saw was combination, the sum. How to integrate root sin x plus root cot x, root tan x plus root cot x. I hope you found this very useful, and if you did, please do not forget to share it with your friends. So until we meet next time, it is goodbye from Max with Aarti.